So wonderful. Good afternoon, dear LinkedIn community and composites experts out there. Today we're gonna talk about R&D platforms and incubation platforms. My guest today is Timo Huber, and Timo right now is in China, and he will tell you which province and which city he is from. Welcome, Timo, to my show.
Thank you, Ilka. Thanks for having me today. Basically, I'm in Changshu, which is in the northern area of Shanghai, so about 1.5 hours away. So welcome, good afternoon to you here in Europe. So it's already evening, so here in China, it's 7 o'clock in the evening. Yeah, thanks for having us.
Absolutely. Yes, evening time. And let me show the community the great layout behind you. Can you tell us what's behind you?
Yes, I can tell you. So in principle, first it's a screen. But behind that, it's our showroom. What we are using here for the ACTC and for the HRC group to show our customers, our partners, so the working area, some examples of our parts and so on. And I will also invite you in a second then to enter here in the showroom, and then let's have the talk, yeah?
Absolutely. So that's really a great atmosphere you are having there. And as you said, it's already evening over there. So, but we have enough lighting so to show you a lot of parts, composite parts that are created by ACTC in conjunction with the HRC group. Yeah, Timo, he's based in Germany, and we will talk about that also. But right now, as you see, he's working from China, and this is actually the first time, a debut, that I have a guest logging in from China. And therefore, dear community, please write in the comments whether you can see us and hear us in a great way. A LinkedIn Live is often a technical construct and something can go wrong. We are also streaming live in parallel on YouTube. So if you encounter any difficulties with LinkedIn stream, then go over to YouTube. Just put in my name, and then you can watch also this live on YouTube. Other than that, I'm also greeting now our podcast guests, because we will also prepare from this tone track a podcast that will be released on Spotify, Deezer, iTunes, and all the other prominent channels. So, if you are here today at this live, we would like to hear from you the picture, the tone, and where you're tuning in from. And also, because we're talking about composites, please let us know, are you working with composites? Do you have any composites frameworks, processes, products? Write them in the comments and connect among each other, because this is today all about composites. So let's talk in the beginning, while I'm seeing that already a few people are joining us. Let me ask you first to introduce us a bit more formally, ACTC, and what is the relationship to the HRC group, dear Timo.
Okay, yeah, perfect. No worries. So, yeah, in principle, the HRC group is a provider for composite lightweight solutions. We have a strong focus on carbon fiber. So every component which is related to CFRP in different market sectors like the automotive or aerospace industry is served by our group. So the HRC group in total has around 2,200 employees at the moment. And within this group, the ACTC, the Advanced Composite Technology Center, is our R&D, so research and development and incubation platform for our internal development, but mainly for the developments what we are doing together with our partners or our customers. So in principle, I'm responsible for our R&D activities here within the HRC group, leading the center here as a vice president. And yeah, I started this journey more or less exactly 5 years ago. So in January 2019 was actually my first working day here.
So I'm back. I'm just reading some of the comments, which I will be going back later on. So, Timo, let's dive into actually shall I call it USP, unique selling proposition? So your company ACTC is a R&D center and an incubator platform. Just in the beginning, let us immediately dive into it. What is the similarities and the differences to, for example, a testing house, a testing institute?
Yes, that's a good question. Yeah. So in principle, we are following with this center an applied research approach. Means, I mean, everyone who is based in Europe or even in Germany, I think, knows the Fraunhofer, which is European or probably also globally the biggest institution for applied research in different sectors. And this applied research concept is also the one we are following here with this center. So we are trying to close the gap between the fundamental research, so producing all these new nice ideas in universities or in this fundamental research, and then help our customers, our partners to transfer these basic observations and innovations, to transfer it really in applications. So that's our so-called applied research approach, what we have here, which makes us a little bit different from the research usually manufacturers are doing. So we're doing it as well in our HRC group for sure. But these developments are mainly focused on the product itself, right? So it's a project-based research and development, what they are doing there, optimizing and parts, for example, for the customers, finalizing the shape to be really, or to have a producible part and so on. And we are independent from this production focus here at the center. Makes us a little bit more flexible in terms of what we are doing, how we are doing that for our customers. And we are also different from a, I would say, typical testing lab, which is usually providing services like material testing, material characterizations, and so on. This is also something what we are doing, but again, very independently, on only focusing, for example, on the study on material properties, material characterization, but always in the context of our holistic research approach. That makes us a little bit different here. So in principle, every equipment and technology what we are offering here for our customers in our technical shop floor here is all full and production scale. Means we are not working on a lab scale, on small scales or coupon level. We can really support our customers up to at least prototype or even small series production, what we can do here on site.
Yeah, prototype sounds, of course, interesting, because prototypes always include cost for the tooling and things like that. How would you rate your tooling cost? Do you have prototype tooling and serial tooling separate? How do you deal with that?
That really depends on the application and also on the customer, the project. It's for sure we have, for each processing technology, we have different molds and tools available, for sure, because the tools are very much relevant when we are talking about composites processing, because you manufacture composite during the process. But mainly, I would say, blade structure, generic structures, and so on, which can be used for a different kind of a little bit more basic R&D topics here together with our customers. When it then comes a little bit more into demonstrator parts, prototypes, then it's usually by using customer tools. So they bring the tools with them, or we design it together and we let them produce here and then put it here on our equipment at the ACTC and do the composite manufacturing process. So it really depends on the project. We have, for every technology, we have a certain number of tools available. As I said, mainly simple geometries like blades, like beams and whatever. And when it comes then to more complex parts and more related then to the final application, real prototypes, that belongs usually then to our customers and partners.
So you have an assessment plan in place, I guess, and you are assessing then which tool comes into effect, right?
Yes, absolutely.
Okay. So in your business, I guess and would expect that you have to do a lot with grants, supports from the government, the European Commission. How is your experience with these sort of financial instruments?
Yes, so actually we are based here in China, so the in Europe usually used funds are usually not fitting to our company structure, but at the end it's the same here also in China. So there are programs which are funding different topics. I mean, lightweight is a topic which is around since quite a certain time. But when it comes here now to more application-oriented developments in lightweighting, adding new functionalities or even new applications, new market sectors, and making that ideally all sustainable, then there are also a lot of programs here very similar to what we have in Germany or in Europe, means that we have it on a national basis, like national funds here, which could be granted then for several topics. Mainly also collaborative projects, means you have here also then partners like universities or other industrial partners to work on a joint project here on a specific topic. So it's very similar approach. Also, international grants are in principle available, not nowadays. So it's depending on the programs of the commissions and the authorities. But also in the past there were these different kind of collaboration projects on different topics, where for example the collaboration from different countries or companies or research institutions of different companies can join their forces and work together on a specific topic.
Thanks for these insights, Timo. Very, very interesting. Now, we're talking here about new product development. And one of the concepts I came across during my innovation coaching with the European Commission is TRL. That is technology readiness level. Do you work with these levels? And can you walk our audience through this technology readiness levels? What these levels actually mean, and when is, for example, market fit there?
Okay, no, that's a good question and a good topic, because also we are using that kind of classification. And before or while answering this question, I would invite you to come over in the showroom.
Okay.
To let you know a little bit, or to see at least some of the parts and topics we are working on. So as I said, so this is our showroom presenting some of our parts which we are allowed to show from our customers' perspective. And yes, your question is about the TRL, the technical readiness level. I mean, that's a kind of classification, right? A scale to describe the maturity of a technology. I think the origin goes back already to the late 1980s, and I think it was first described and used by the NASA from the US, right? But that time really focusing on space technologies. But in principle, nowadays or during the times, this classification was also then used different sectors. And I think nowadays it's not really, I would say, a standard. I think it's more a solid common understanding of how to describe the readiness of a technology. And also the European Commission, as you said, I think they implement this TRL scale with the Horizon 2020 program, if I'm right, to precise a little bit the targets in their programs, that also the potential participants of these programs know exactly, do I fitting with my idea, with my innovation? Am I too far already in the developments, means TRL or higher TRL, for example, and or am I too low or whatever? So in principle, that's my personal perspective, is that this TRL scale is very suitable to describe the readiness of a technology. Not only from this very technological aspects, but also from the market maturity. Means, is this already something I could find in the market? That could be also something interesting for a customer or for a part producer, because perhaps I have an idea, a new process, a new material, whatever, thinking about, can I use that in my applications? Then for sure it would be nice to know if it's perhaps used already in another application, which is similar or completely different from my products. And coming back then to this common understanding, knowing where I am with my developments and where do I want to be in a certain time, I think the TRL is very suitable to describe this level of development.
Fantastic, Timo. So we are getting some comments regarding the showroom. People are saying it's a nice place there. Yeah. So
Thanks for
yeah,
that.
show us around. Feel free to show us some parts about your innovations.
Yes. So what you can see here, so let me try to focus the camera a little bit. As I said at the very beginning, so the HRC group is working in different market sectors. So we started our journey and our business in 2014. So actually this year we have our 10th anniversary. And that time we were starting in the automotive market, okay? And this is still, I would say, the major market sector in terms of our business. So automotive means different kind of parts from the exterior, interior, structural parts, mainly, as I said, carbon fiber based. So we are talking here always about CFRP parts. We are talking about exterior parts with this nice carbon look, as someone or most of you probably know. So I can place, for example, one part here in the camera. So you have this nice carbon pattern here on the outside. So I mean, that's, I think most of the people know that on this nice carbon look. So that's one thing. So we are doing these kind of parts for the automotive industry for exterior, cosmetic, aesthetic applications here. Could be on a small scale like mirror caps, but could be also larger parts like engine hoods, trunk lids, side panels, door panels, and so on. And you can see here a variety of different applications. We can move a little bit in this direction. Then you can see also, I will take the camera for you. Then you can see also such a front part here of a car, also in this carbon look. And for sure, as you can imagine, that's yeah, mainly serving the sports cars industry, the supercar industry here. We have also some parts like helmets here in our portfolio, means also carbon-based shell design here. That's here's a little bit more complex part, an air intake box from a hybrid car, what we developed together with our partners. You can imagine that's already very comprehensive and very complex parts here, because it's not that nice flat structure which you can find very often in carbon look, but also all here this geometry, which is, I can tell you, not that easy to manufacture. So these are a different kind of parts here from the automotive sector. You can also see here a battery cover here, fully made out of CFRP here, which is definitely a topic when we are looking for more mass production and more suitable solutions for the automotive industry. So it means higher volume. Then we are talking also about SMC solutions, for example, for such a battery case. And what you can see here, that was the output of a research program, which we did together, for example, with Fraunhofer ICT. So that was a development here focusing on this EV market, means battery housings, battery covers. You know, they need to fulfill different requirements. For sure, you have all this mechanical performance, which needs to be fulfilled, but also topics like EMI shielding, flame retardancy, and so on. And this is something we are working on here together with our partners, with our customers. In that case, that's also a generic part, so that's our own design of such a battery cover. But in principle, it could look like this. So we have, in principle, an SMC co-molding process, what we used here. And also the interesting thing is that I think you can see it right now. So we use here these local reinforcements here made out of prepreg material. So it's a co-molding process to really reach a very high performance by having very low weight and therefore a very high lightweight potential. We do also, I just switch around this direction over myself, and then you can see here one of our bigger parts. Means that's here a sidewall of a car, all made out of carbon. Also topic here, the wheel, composite wheels. I mean, that's also something not new to the market. There are already many or several solutions on the market, but to produce them in a high volume suitable process, that is something, for example, which could be a little bit more innovative compared to this very handmade process what you can see at the moment in the market. So coming back to the topic of the TRL, I promise you we go also to the flying car over there later on, but most of you have seen it already because we displayed it on the check last year. But nevertheless, we will go there, no worries. Coming back to the TRL, Ilkay. So as I said, the TRL is a scale for classification of the readiness of a technology in our understanding. So we have different steps. So it starts with TRL1 and ends up with the TRL9. And I would not go in detail for every step, but in principle you can subdivide in three areas. So the first three steps, so TRL1 to 3, they will end up more or less in a proof of concept. Okay, so means TRL1, for example, is the observation of a new phenomena, a new material, a new technology, and so on. And as I said, then going through these three TRLs, you will end up in a proof of concept. The next three steps, so TRL4 to TRL6, this is then ending up in a demonstrator part, in a prototype, for example. So means that we take this proof of concept and transfer it then in a demonstrator, in a complex part, in a generic part, end up here in a demonstrator. And after that, you prepare more or less your series production. So the last TRLs 7 to 9 is then really, I would say, the pre-series development, putting the demonstrator in the right environment, how it will be used at the end of the day in your final application, and make it more or less ready. So we here at the ACTC, we serve more or less all TRLs, okay, 1 to 9 in principle, because we also study new ideas and trying to find new inventions in terms of processing, but also in terms of materials, for sure also concepts and engineering. But I would say usually we are in the area of TRL 3 to TRL 6. So this is more or less the main area where the ACTC is working on internally for our own development, but also for our customers and together with our partners.
So Timo, thank you so much for the tour. We are getting a lot of praise from the community regarding your presentation here. And we have also some comments that are coming from both YouTube and LinkedIn. And are we ready to answer some of those questions, Timo?
Yeah, absolutely. Please go ahead.
Okay, let's give it a go. So there is, I will show you the comments, and I will read them for our podcast guests and also so that you can answer those. So our guest says, this is fascinating. Would love to learn more about the cutting edge composites research happening in China. So let me interpret this the aspect of this question. There is a comparative first of all, there's competitive advantage and there's comparative advantage. So this touches the question of comparative advantage. Why is China so much advanced in this technology? Because you know both worlds. You are in Germany, Europe, and you got China. What are the advantages that you can combine in order to get great solutions for the customers?
Mhm. That's a very good question, and scratching in principle a huge topic. So we can talk about this, I think, for hours. The difference between the development and also the development speeds here in the different regions in the world, right? So I'm obvious German, and I did all my lifetime so far in Germany with my studies and so on, working for Fraunhofer more than 12 years. So I think the main difference I personally saw already from the very beginning, and now it's I think it's more or less mature that it is like this, is that sometimes, not generally, sometimes, and based on my experience, in Germany and Europe, for sure, we have great ideas and we have fantastic innovations and so on. Sometimes, especially for Germany, but it's my personal opinion, the next steps then to bring it in real application sometimes is a bit too slow. Thinking too much about the things which can go wrong, and to develop everything 100% before trying and really doing the next steps could be for different applications the right way, absolutely no doubt. But sometimes, especially when it comes to very dynamic market situation, what we have what we have in automotive right now, to all this transition from the, say, the past automotive industry into the new and the future automotive industry, with all the transition into EV mobility and so on. It's very dynamic, and so you need to follow the market in the same speed the market demands for that. And another example is the eVTOL market sectors, like you can see here in the background. So this flying car, what we are showing there, it's so dynamic, and for sure there's no time to develop a 100% solution and then bring it in application. You need to be a little bit faster and perhaps also a little bit earlier to start really going into the applications with your innovations. And that's, I would say, for me personally, the speed, that's the main difference. While we are sometimes in Germany still thinking about that, and as I said, also thinking about what can go wrong, the Chinese are doing it. Sometimes a little bit too early and then fail, but then standing up again and do it hopefully better. But in many technologies, in lightweight, for me, is based on composites, is such a technology. It is matured. You have a lot of experience already gained from different market sectors, and now it's time to go the step. And that's, for me personally, the main difference.
Yes, I totally agree. Speed is the new grade. I read this morning on LinkedIn from Dirk Kreuter, and we had a post this morning from Natalia out of Dubai, or is she in Bali right now? She was comparing in that case, the American and the German way of entrepreneurship, and she was actually exactly explaining that what you were explaining. In Germany, we are too much focused on the specifications, on the technologies, and we want to have everything perfect before we roll something out. And in a VUCA environment where we have a lot of ambiguity and where we have uncertainties, sometimes reactions have to be faster. And I think you are doing a great job in that you take both advantages and play on that. I would like to continue with the questions because they are coming in very fast, Timo. So we've touched on this already. Amazing tour, says Patrick. It's great to see how a dedicated space for composites R&D can foster innovation. How can other countries replicate this model? Do you have a recommendation of how other countries can replicate this model? Is there something that you think is salient and important to watch out for? Thanks, Patrick, for this question. Great one.
A great one, but to be honest, hard to answer. For me, which is also the basic here of the ACTC, to team up with the right partners for a certain topic, for me is always the best to push innovations, to bring innovations in applications, because at the end you cannot cover everything by your own, right? When we are coming to composites again, so you have the material side, you have all these raw materials, you have the resins, you have the fibers, and they have all so much knowledge here on their material, and they understand their material the best. Then we have the other side, we have the application itself, and now we all need to bring them together. So we need to manufacture these composite parts. So the processing is also playing a big role. You mentioned at the very beginning the toolings. For sure, that the tool is not only a tool, it's part of the technology. And to work together on a certain topic, bringing complementary competences together, it's, for me, personally for me, it's the best way and the most sustainable way to move further. For sure, sometimes you can go faster if you're going alone, that's absolutely for sure. And for some limited applications or topics might be absolutely fine, but for such a holistic research area like the composites are, with this huge amount of different applications on the markets like automotive, aerospace, sports and leisure, the hydrogen industry with all these high pressure vessels nowadays, you cannot do everything by your own. And in that case, I would always recommend to look for the right partners. And that could be for sure, or that should be for sure, local partners which know their local market the best, and then team up on a national basis, on an international basis. So we are having partners on a very much international focus basis here. For sure, we are working very strongly together with Fraunhofer as a strategic partner here of HRC Group, and especially in the ACTC. We have different other partners from the research area in Germany, like the RETH Aachen, the ITA Institute. We are working with different institutions also in Spain and in Italy. And it really depends. And finding the right partner to build up something together, for me, that's the key. And for us, at the end, so far, it's a quite successful approach. Ilkay, sorry to interrupt. I cannot hear you anymore. Is it just me?
Yes. That was my fault.
My
fault. The mic was off. While you are speaking, I'm turning the mic off to get away from the background noise. So Mohamed Shariful is saying advancement in composites technology are mind-blowing. And I really have to say, Mo, you are right. It's the advancements that we did as an industry in the past several years is very much regarding the output, is getting higher, the takt times is getting higher, the quality, the surfaces, the coatings, the fibers, everything is getting much higher, and it's really mind-blowing. I totally agree. And then we have Thomas here from Langzauner GmbH. This is a company in the north of Austria, and they do these presses, 1,000-ton presses. Yeah, companies like Airbus, they are using their solutions, and I'm really happy, Thomas, to have you here today as the CEO and owner of that company. Great machines. And I will have also Thomas interviewed during Jack World, which will come also later on with you, Timo, in a moment. So stay tuned on that one. And then from YouTube, the questions are coming in. And she says she's the grown-ups guide to running away from home. Interesting title. She says, is there any particular breakthrough that you are especially proud of, Timo? I'm sure you're proud of everything, but is there something where you say, this is particularly interesting because that is changing society, that has the potential of having disruptions, and I'm seeing you are walking in the right direction, so I get me out of the picture so that we can get the full view of where you stand right now.
Yeah. So no, that's it's hard to answer. So I would not be able to really nominate, I would say, the best solution what we ever developed here. as we are moving in this TRL 3 to 7 stages, so we end up mostly in a prototype, and then together with our partners, or even the HRC group with the manufacturing capabilities, we then transfer it in serious production. And for me, I'm an engineer. Every idea which is ending up in a real application is a success and makes me very, very proud. And luckily we have such topics already, what we were able then to really bring in applications we are about to do. This is something I could not talk that much open today, but at the end you will also see at the JEC in Paris in a few weeks some news at least, and also some new applications what we will introduce first in the Czech.
So we've seen Daniela, she said a flying car. Yeah, that's behind Timo's area there. What we have also is Mo said, great products, congratulations. Thank you, Mo, for tuning in. That's wonderful. And then we have from LinkedIn, Martin says, how about certification for example, CPVs and VTOLs? Can you assist the certification process for our community, for clarification's sake? Yeah, I like those acronyms, but maybe Timo, you can explain what CPV is and what a VTOL is, and then answer the question of Martin. Thank you, Martin, for your question.
Yes, for sure. It's a good question. Yeah, so CPV stands for Composites Pressure Vessels. So perhaps we can quickly go there. Just follow me for a second while I'm explaining that. So Composites Pressure Vessel means, in our case, hydrogen storage systems. That's also a topic we started working on roughly 4 years ago, as you can see here now. So that's a typical high pressure vessel here for the storage of hydrogen. We are focusing here on so-called type 4 pressure vessels, mean that we are using such a thermoplastic liner, as you can see here. Could be a polyethylene, HDPE, or could be a polyamide, for example. This one is then combined with so-called thermoplastic boss parts. I will show you a little bit more in detail. So you have these boss parts here made out of metallic, which are somehow assembled together with this thermoplastic liner, and then we wrap around here a certain amount of carbon fiber to produce this composite pressure vessel. So that's more or less the description of this CPV. And as you can imagine, when we are talking about such pressure vessels with working pressures, for example, up to 700 bars here, they need to be certified, right? To be ready for usage in automotive, in the commercial vehicle sector, or in the aerospace or whatever. So the certification is mainly done by third parties, named by the authorities, depending on where you are. And for sure, yes, we are helping our customers to prepare everything. So we do the developments, for example, for such pressure vessels together with our colleagues from Ingenuity, who do the design, the simulation, the engineering around that. And we are doing all what is necessary to produce such parts. And then finally, we can also test it in-house. But to do the certification, you need to have someone who is authorized to do this certification. So the answer is yes, we are supporting our customers here. Same is for the eVTOLs. So the certification is always the issue of the final user of the component, right? Or the OEM who is selling that to our customer. So for sure, we are accredited with all the standards which are necessary for a parts manufacturer to serve these markets. And we have everything also here in place to do at least all the preparation work which is needed, then knowing the certification boundary conditions and forming all these developments in the right way to make our customers then able to do the certification with the authorities or the authorized third parties.
Okay, so now it's clear what a CPV is and a VTOL is, and you are in all these applications. So there's an interesting question from Delva coming in. So he congratulates you guys for showcasing the composites innovations. But is there something unexpected as a discovery or application that you came across so far? So that I would like to touch also based on the resin systems. Yeah, there is a thermoset and thermoplast resin systems. Do you work with both systems? And is there anything that came up lately where you found something interesting on it? Because I know this industry is testing a lot on resin systems. Is there something that you can highlight?
Yeah, that's true. What you stated, Ilkay, is true that we are working with both material systems. Okay, so we have on the one side all this thermoplastic route or thermoplastic based composite, and we have these thermoset based composites. In our production, we are still mainly working with thermoset materials. In pre-preg autoclave, in pre-preg compression molding, in sheet molding compound, SMC, and other technologies. On the other side, we see also a big trend, also in the automotive industry, aerospace industry, using thermoplastic composites. I mean, this is true already since many, many years, not only here, but more or less on a global scale. To find the right material for your specific application, to answer this question, that's basically one of our service offers what we give to our clients. Because in many cases they come to us and say, okay, I have a seat structure or whatever, I will or I'm thinking about to produce this part in fiber-based composites in future. What is the right material? What should I use? Should I go for thermoplastics, thermoset? What kind of fiber? Is it a carbon fiber, glass fiber, or natural fiber, whatever? And to helping our customer exactly to answer this question, this is more or less describing our holistic approach. Okay, we start really from the idea, from the requirements analysis together with our customers, and then going in this big pool of different materials and different processes, and then we will end up again then with the final developments of how to produce it in a serious production, these kind of parts. Coming back to the question, yes, there are material developments for sure continuously ongoing. We are working very closely, especially here at the ACTC, very closely with material suppliers because they know the material, they do the material developments. And for sure, one of their headlines, as for many others as well, is for sure sustainability, right? Means how can I, or what do I need to do to make my material solution more sustainable? We see developments in these areas for thermosets, for example, when we talk about epoxy, which is still used in many applications. They are also trying to develop new materials, new bio-based materials, where they can at least replace some of their components in the epoxy system with material components based on renewable sources. Same for fibers. We have all the synthetic fibers. We have a carbon fiber, so which is also the material which is mainly used here at the HRC group, which is a very cost-intensive material, right? And also an energy-intensive. So the carbon fiber itself, it has a big backpack already in terms of the CO2 footprint. And to end up in a sustainable lightweight solution needs to have an holistic approach. Means you need to start from your raw materials. You need to consider all what is necessary to produce a composite part out of that. And then you have the usage phase and the end of life, which also needs to be considered already from the very beginning, from the engineering. Means we are looking to that, and we are working on that very intensively with material suppliers. Same is for the thermoplastic side. I mean, all of you who are knowing thermoplastic materials, you know that thermoplastic materials has a really broad variety of different material classes, like the commodity polymers, like polypropylene and so on, and then going up really to the high performance, high temperature materials like PPS, PPA, peak material, PEG materials in combination with carbon fiber. So we can serve a lot of different applications with a lot of different materials, also in thermoplastics, but finding the right one, not only from this mechanical performance perspective, but also, for example, from the sustainable or sustainability aspect, how to reuse them, how to recycle them after the lifetime. What about the process? How many energy do I need to spend into the process and so on? So these are all questions needs to be answered to find the right materials. And this is also a question what we are working on with the material suppliers at the end here at the ACTC.
Okay, great. So all these questions are so far answered. Timo, my last question is, while we were talking about the fibers and the resins, now let's talk about the processes. Do you have several processes in-house? Do you develop yourself processes? And if you develop those processes, how do you go about them? So now we see again the fantastic look into this showroom, dear community.
Yes. Please, allow me to change a little bit the perspective, then you can see everything more or less a little bit clearer. Let's go a little bit closer to here. You can see our corporate video in the background while I'm describing or talking a little bit about our process offerings here. So in the ACTC, we are looking a little bit more on mass production process technologies. Okay, so means on different aspects from thermoplastic to thermoset, from large volume to mid volumes and so on. So when we are talking about thermoset resin systems in combination with discontinuous fibers, for example, SMC, sheet molding compound, we are focusing, for example, on the development of carbon fiber based SMC here. So develop the material itself. In SMC, we are also able to produce our pre-preg, so the SMC material by ourselves on our SMC line, what we also here have installed in our R&D center. And then use it in compression molding, for example, to produce such parts as I have shown you just before, the battery covers, for example. When you're talking a little bit more to the high performance applications, for sure we need to incorporate a continuous fiber. Could be used in pre-preg autoclave, pre-preg compression molding, wet compression molding, HPRTM, so high pressure resin transfer molding, and also pultrusion is something what we are looking on for different applications. The same, more or less the same broad range on the other side, on the thermoplastic sides. So we are working here also, when we are talking about discontinuous fiber reinforcements, we have injection and compression molding here available at the center. And when we are talking about continuous fiber reinforcements, we are starting mainly with the tape material. So we are focusing very strongly on the tape and the tape laying, making a monolithic blade out of that and doing a forming, a back injection molding or a back compression molding here. In the back, you see sometimes some video sequences from our inside here. When we are talking about processing equipment here at the ACTC, we are always talking about full industrial and production scale. So not meaning on a lab scale, on a small scale to produce some samples or coupons. We really have the capabilities with our equipment to produce on a production and full scale here. As you have mentioned, the press force, for example, our big press has 2,500 tons clamping force, which is used for SMC, RTM, wet compression molding, these kind of processes also on the thermoplastic side. We have a fully automated cell here for the HPRTM and wet compression molding with another 1,000 tons clamping force press here with this unit. So it's really equipped with full-scale equipment here for the different kind of materials and processing routes.
Yes, interesting. So processes are always the heart of any organization, and I'm happy to hear that you are constantly evolving those processes. in-house. Now, before we come slowly to the end, let me talk about sustainability with you, because one of my pillars besides technology and innovation is sustainability.
Mhm.
Um, how about the product life cycles of composites? Let's talk also a bit general. Let's take the big picture, the bird view. You are, Timo, an expert in composites. For me, you are a thought leader in this. Let me know how you would classify composites in sustainability.
Yeah, that's a good point. From a bird's perspective, I would first say that sustainability needs to have a holistic consideration, because when we are talking about sustainable solutions at the end, as I raised a little bit already, you need to consider all aspects of the materials, of the process, of the lifetime, and the end of life. Right, means what to do with the part after the lifetime, and to do this in the right way, it is necessary not only from the requirements coming from the authorities, from the future laws, also from our customers, but also for sure when we are talking about our footprint, our daily footprint here on this planet, and therefore. The sustainability is really not only a headline for us in the HRC group. I can give you some examples. I mentioned already the material developments, which are very linked to the cooperations with the material suppliers, because they are manufacturing the materials. We are choosing the right one. And looking on the CO2 footprint, for example, they bring already with it. We are strongly focusing on the processing, so how to manufacture such composite parts and components here, and to also cover the topic of reusing it, recycling that. We decided more than 2 years ago to establish our own circular economy approach internally by the development of our own technology in terms of a pyrolysis system. It's a microwave-based pyrolysis system, what we developed and installed here internally. So every production waste which we see, and it's coming from the production, from the pre-break cutting or whatever, could be directly put in this recycling process. And what we can get out of that is a reclaimed, is a recycled carbon fiber, which is not continuous anymore. Yes, it is a discontinuous fiber. It's more or less a chopped fibers. But then we have different routes and different possibilities to reuse this fiber. Could be the step we are a non-woven, for example. So we can build up a non-woven 100% out of recycled carbon fiber, then introduce it again in our processes, which means a resin transfer molding, wet compression molding. We can make an SMC out of that, for example, and do then also a compression molding out of that. Or we go the way that we do already a pre-preg again, means that we combine this recycled carbon fiber with, for example, a thermoplastic fiber system, could be a recycled polypropylene or whatever, mix them together and make also a plate out of that, which we can then directly use in thermoforming, back injection molding, and so on. There's another topic ongoing, which I cannot tell you right now, but will be sooner this year, is also how to recycle and reclaim a continuous carbon fiber out of an part. For example, we were talking about these pressure vessels. I mentioned already, you have a lot of fiber on it. We are talking about 10, 20 or 30 or even more kilograms of carbon fiber on such pressure vessels. And for sure, you need to have a strategy what to do after the lifetime of such a pressure vessel. And the optimal way is to get the fiber out of the pressure vessel and then can use the fiber as a continuous fiber as it is on the pressure vessel as well, and then going again in a same performance level application like before. This is something we are working together with some partners at the moment. But the other one, which I firstly mentioned, this is already installed. So we are able to 100% use all our income material in terms of these fiber, pre-preg materials and so on. And we are also able to do the end of life recycling for components, composite components we manufacture and brought to the market. Not with our own parts. I said we have the 10th anniversary. Our products are usually still in lifetime, but also other sources we can use here for the feedstock of our recycling process here.
Very comprehensive view, Timo. Thank you so much for all these insights. Very, very impressive and very comprehensive manufacturing processes, products, and solutions. We are having also a comment from a golf site. They find it fascinating. Now, are you in golfing at all? I mean, the shaft of a golf stick is also from carbon, right? Any inroads in that?
Yes, so the sports and leisure industry is also an industry what we serve. Not a big portion, but from time to time there are different applications. So we are working with the shoe industry, for example, to make some special sports shoes with some special carbon inside, let's call it this, to increase the performance. When it comes to a stick application, we developed a solution for a customer. Unfortunately, I cannot name it, but it's a producer OEM for hockey sticks, ice hockey sticks. So it's not really a golf stick, but also a stick for a sporting utilization. And therefore, we developed a production process how to manufacture the stick area continuously in a very effective and efficient process step. Then here as one example how to produce that. Golf sticks for sure would also work. Every application where you need to have a good lightweight or the best lightweight you can get out of that, for sure, composites, fiber-based composites is at least one or the solution for it.
So I'm back. Okay, so you see community, automotive, aerospace. Now we're end up at the sporting industry, and we are coming also now to the end with Timo Huber, who is now live joining me from China. This is fantastic. I'm also amazed about the technology that our StreamYard channel is giving us. We are streaming live right now on LinkedIn and as a backup on YouTube. And really, you guys on YouTube, you smashed it today. We had over 600 live viewers on this show today. That is my personal record. And I really thank you so much for being part of this show and asking all your questions, even though this is a very specific niche. And you brought with your questions very inspirational threads to us that Timo could answer all of them. Now, coming to the last point, and we would like to close this within an hour, this live session. The last point is there is JEC World 5 to 8 March around the corner in Paris. This is the world's largest composites show. And Timo, you will be there, I guess, right?
Absolutely.
So come to Timo on the HRC stand. You see the logo on the top of his picture, and have a look at that. Now, of course, JEC is always an opportunity to show highlights, new things. Anything that you can give us a sneak preview, Timo, or is it too early to talk about it?
What I can do is I can increase the tension already a little bit. So yes, there will be some highlights and there will be also some news, but for sure it should be a surprise for the JEC show. So stay tuned. I think it's, I don't know, 5 weeks ahead, right? So the time is running very quick. So welcome everyone to join us. So we will having a big booth there. So come over. So I will be there all 3 days. You will see definitely some interesting composite solutions for sure, not only in our stand, but I think all over the Czech. So feel free to come over. And yeah, let's further talk on how lightweight can bring some benefits to a more sustainable life.
Absolutely. So then we have another guest, Behrin from Turkey. She says very valuable and thanks us for his show. You're welcome, Behrin. We are always here for the community to answer all these questions, be it live. Please follow the HRC site here on LinkedIn. Follow Timo, follow ACTC. We are all networking here on composites, lightweight engineering. So there's amazing technologies out there. And yeah, also there is our group. I'm the co-founder of Composites Launch. So you see the logo on the top. This Composites Launch is a free online group here on LinkedIn. Please join our group. We started as a German-speaking group because our core is the German-speaking countries, Germany, Austria, and Switzerland. But we are giving a lot of international and English content out there. So please join us, our group. This group is a bit elite, yeah, in that we have a lot of decision makers, the people, the experts out of the industry. You don't find here too much general public. It's very specific on composites, users, composites, supply chain, and anyone who has an interest in composite materials. And just for good order's sake, composites is anything that has minimum 2 or more elements. Yeah. So we have a wide understanding of composites. We have talked today about FRPs, fiber reinforced polymers or plastics. But you have CMCs like ceramic matrix composites. You got elastomers, you got thermosets, you got thermoplast. So you name it. Composite, of course, is a holistic term for this. And anyone who is interested in this, please join our group. Thank you, everyone, for watching this live. I'm seeing there's still a big bunch of people on YouTube here available. Unfortunately, I left my smartphone in the other room. I couldn't check now the LinkedIn engagement, but I'm sure it will be great. This LinkedIn Live, if you have not been here from the beginning, this LinkedIn Live will be now available as replay. You can watch it as often as you like. We will also restream this over on our Composites Launch LinkedIn site later this afternoon, so you can watch it also from there. And I will watch the comments and answer your questions if you have this afternoon any other comments. Other than that, please come to Jack World, talk to Timo, yeah, talk to me. I will be there. I will be at the International Press Club, and I'm also interviewing people live from the show floor at Jack. If you want to be interviewed by myself, by Composites Launch, we have a format called Composites 360 on tour. We're happy to talk with you and brief you how this works. Just drop me a note on LinkedIn, drop me a note on YouTube, write us, and we take it from there. So my last question to you, Timo, is there any call to action? So what should the community watching this live now do after we've finished the stream? What's the one thing you want them to do?
Definitely visiting us at the Czech. I think that's the easiest way to get in contact, to see a lot of other nice stuff here on the show. So definitely this is something to get in touch with other. That would be my last point.
Okay, wonderful. Thank you, Timo, also for your time and for all this nice preparation that you did with this great show floor, but also with the tone, the picture, and everything. This requires some passion, of course, which you have, and I'm glad this was conducted in a very nice way. Now we will watch it also on the replay, but I'm sure it was a fantastic stream today, and I'm glad we have it over. And dear community, see you sometime soon again. Thank you so much.
Thank you so much. Bye bye from China.
Bye bye.